Dear friends, welcome to the online course under MOOC of NPTEL IIT Madras, the course titled Risk and Reliability of Offshore Structures. We are discussing lectures on the course Risk and Reliability of Offshore Structures. It has been established in the previous lectures that reliability is circumscribed using probability theories. Reliability is a positive way of looking at the failure, so that one can develop a level of confidence in ascertaining the functionality of a given system within a specific period of time under given specific conditions. So, we need to understand theory of probability slightly in a detailed manner. So, in module 1 we are talking about probability theories and plausible reasoning. Today we will talk about, on lecture 8, the quantitative rules, which is of course a continuation of the last lecture. We already said, for establishing a logical reasoning between two events A and B, let us say if there are two events A and B, a set of propositions can be arrived by combining this in 4 different forms. Let us say it can be a logical sum, which is A plus B, which we call as disjunction. It can be a logical product, which is AB, which is called as conjunction. Can also be an implication, which says A implies B. The fourth can be a negation other than A, except A. So, combining this in many different forms, one can arrive at set of propositions. However, two important quantitative rules are necessarily for establishing the logical reasoning between the events A and B, or between n number of events, where the knowledge level of each event can be improved upon by adding future information to these events. So, we also said, for expressing plausibility ABC, given D as an information and considering either BC as a single event or AB as a single event, one can express consider or considering either AB as a single event or BC as a single event. One can express as follows: f of x y, where x y has been already expressed in terms of A and B events, which we discussed in the last lecture, can be said as f of x and f of z and y, called equation 1. This equation was established in the last discussion, which we call as associative equation. Now, we can say the above equation is called associative equation. This equation has a trivial solution, which is given by f of x y is constant. So, the trivial solution of the equation 1 is f of x y is constant. But unfortunately, this solution violates one important condition. Violates an important condition. Can you tell me what is the condition? Yeah, it is important to note that the monotonic requirement is violated. Of the function to remain continuous is violated, and therefore, this trivial solution is of no use. Then what shall we do? Let us look at the following abbreviations. Let us now look at, let us see the following abbreviations. Let u be expressed as f of x y, let v be expressed as f of y z, and then f of u z can be expressed as same as f of x v. One can differentiate the above equation 3 with respect to x and y. So, differentiating equation 3 with respect to x and y, let us say we get f1 u z, f1 x y can also be f1 x v, f2 f1 u z, which can also be further so f1 x v, f1 u z and f2 x y. Yeah, we have to have the differentiation also, which can be further said as f2 of x v and f2 of y z. Now, the above equation after differentiating equation 3 will lead to the following statement. Now, the following statement what we infer from equation 4 is f2 of x v, f1 of u z by let us say f1 of x y is same as f1 of x y y jagah v, x1 of x v, f2 of x y. Having said this, let us redefine the following. Now, let us define g of x y be f2 of x y, f1 of x y. After saying this, we can write as follows. So, the following statements are now valid. U now can be expressed as g of x v f1 of y z, which is as same as g of x y. I can rewrite the above equation 7 slightly in a different form. V can be g of x v f2 of y z, which can also be said as g of y z and g of x y. Now, one can denote the left hand side of this equation as u and v respectively. One can rewrite equation 8 slightly in a different form. So, let us say, I should say rewriting equation 8 slightly in a different form. Partial derivative of u with respect to z can be partial derivative of g x v f1 y z. I am picking up the same thing, f1 y z divided by dou z, which can be also said as partial derivative of g x y with dou z, which can be set to 0. So, rewriting dou u by dou z can be dou g x v dou f y z divided by dou y dou z. I am making a partial derivative of this also, which is dou g of x v f2 of y z by dou y, which can be said as dou v by dou y. Call this as equation 9a and equation 9b. The above two equations or set of equations 9 implies that equations 9a and 9b implies that v is expressed as gxy and gyz. Which is independent of y. Therefore, the most general function gxy can be given by the most general function gxy can be given by gxy is actually equal to r h of v by h of y. Where r is a constant and h of x is arbitrary. Now, as we all understand that function f is a monotonic function, since f is a monotonic function, for g greater than 0, it is compulsory and it is required that r should also be greater than 0, then only the function can be a monotonic function. In such cases, f1 of yz can be expressed as hv by hy f2 of yz, which can be said as r of h of v by h of z now, because I have a variable now z in this case. Equation number 11. Now, the relation dv is equal to df of yz, which can be expressed as f1 of dy plus f2 of dz takes a different form now. So, let us say the form is now dv by h of v is dy by h of y, which is dz by h of z, which is a very interesting classical equation. Equation number 12. Now, the non-trivial solution of this equation 12 is given by let us say w f of x y is w of x w of y. Let us now introduce the following. Let x be b given c and y be a given b c. So, using equation 14, let us try to rewrite slightly the above equation. Probability of a b given c can be simply probability of b given c multiplied by probability of a given b c, and you are able to recollect this equation is the classical product rule. This is the classical product rule. In the above equation, one can see that the probability function should be positive, continuous, monotonic function, which can be either increasing or decreasing. So, there are two limiting cases now. Let us consider what are those limiting cases and check the validity of this equation. First case, say A given C is certain, it is going to happen. Therefore, this satisfies the following condition, which becomes mixed true. So, the following condition are now true. Let us say what are these conditions. Since A given C is certain, A B given C will be as same as B given C, because A given C is already certain. A given B C will be as same as A given C, because B is not going to influence much, because A is already going to happen, because C knowledge has made it certain. Now, by expanding the above relationship, we will use product rule, which just now derived. We can get probability of A given B C, probability of B given C is as same as probability of A given C, which is probability of B given C, which is as same as probability of B given C. This equation implies that, let us say equation number 17. So, equation 17 implies that, if you look at the equation carefully, you will realize that probability of A given C is unity in this case. What does it mean? Which means it is certainty. So, that is one of the limiting case. Let us take the second case. The second case obviously could be A given C is impossible. These are the two extremes. In this case, the following condition is necessary. So, following conditions now are necessary. Let us say what are they? A given B C should be as same as B given C. A B given C should be as same as, okay, A given B C should be same as A given C. A B given C should be as same as B given C. Let us call C equation number 17A. Now, by expanding this relationship, by expanding and using product rule, we can easily write, and using product rule we get, let us say, probability of A given C, probability of B given C is as same as probability of B given C. This equation of course holds two values, two possible values of the above equation says that either probability of A given C can be 0 or it can be infinity. If we choose the solution, so let us say if we choose probability of A given C as 0 as a convention, then this will result in 0 less than probability of the function less than 1. There is nothing but the value of the level of confidence of any specific event is lying between the value of 0 and 1. Therefore, plausible reasoning is connected to probability theory by a real value which lies between 0 and 1. Now, let us talk about the next quantitative rule, which is the sum rule. Let us talk about the sum rule, that is the next quantitative rule. Let us say plausibility A hat is related to A by some knowledge level, in sense related to plausibility of A. Now, one can easily write, therefore, probability of A given B plus probability of A hat given B is unity. It is interesting to assess whether the set of these rules are adequate to design or to decide the plausibility of any logic function A1, A2, A3, An, etc. Is this set sufficient? Now, this is a question. Is this set sufficient to assess the plausibility of any logical function which has components of A1, A2, An. So, we would like to have a general formula for the logical sum A plus B. By applying repeatedly the product and sum rule, we can explain this as below. Let us say probability of A plus B given C is of course 1 minus probability of A hat B hat given C. Which can be said as 1 minus probability of A hat given C, probability of B hat given A hat C, which is expanded as 1 minus probability of A hat given C because I am having commonness in this, I am trying to take it out. I am saying it is 1 minus probability of B hat given A hat C. Which I say probability of A hat A given C plus probability of A hat given B C probability of B given C, which can be same as probability of A given C plus 1 minus probability of A given B C probability of B given C, which can be probability of A given C plus probability of B given C minus probability of B given C, probability of A given PC, which can be said as probability of A given C plus probability of B given C minus probability of A B given C. So, we discussed two important quantitative rules. One is what we call as the product rule, other is what we call as the sum rule. Let us take the discussion forward to discuss qualitative rules. Now, let us talk about the relationship of deductive logic and different forms of plausible reasoning, which is presented in the earlier lectures. The deductive logic is based on the fact that if A is true, B is true. This can be expressed as, let us say, if A is true, B is true. This is what we call, this is, let us say, deductive logic. This can be mathematically written as probability of B given AC is same as probability of, because C is a knowledge data divided by probability of A given C which should be same as probability of A given C, because there is a certain event to occur, that is a plausible reasoning. So, if A is true, B is true, which implies that the statement A implies B. If B is false, so this implies that if A is true, then B is true. If A is false, then probability of A given B C can be expressed as probability of B A given C. Obviously, you cannot use this because this is false, divided by probability of B given C, which can be now set to 0. You can call this as equation number 22, this as 23. So, if A is true, then B is true. So, if A is true, then B is true. Therefore, one can say a condition A implies B. If B is true, A becomes more plausible. Therefore, one can express probability of A given B C as probability of A given C probability of B given A C divided by probability of B given C. Equation number 24. But since probability of B given AC is being used here in the numerator is actually 1 and probability of B given C is used in the denominator here is less than or equal to 1. We are not sure about the occurrence of the event, hence we can write the above equation slightly as probability of A given B C, which is here, is greater than probability of A given C. So, the knowledge level of B along with C has improved the confidence level in expressing A if you have only one data of C which is giving the confidence level of A. So, equation number 25. So, one can write probability of B given AC is obviously now greater than or equal to probability of B given C, and probability of A given B C is probability of A given C multiplied by probability of B given C, B given A C divided by probability of B given C, which can be expressed as probability of A given B C is greater than probability of A given C, which we already had established here. So, in the above qualitative rules, we have seen that how plausible reasoning is connected to probability theory. Now, one can appreciate a basic statement that reliability is a mathematical way to assess the confidence of occurrence of any event usually this event is occurrence of failure. So, reliability though circumscribes with probability theories, it also has inbuilt support of what we call logical reasoning, which comes essentially from the plausible reasoning. So, plausible reasoning are nothing but rules of thinking of human brain. So, for probability theory or probability, which is useful tool in reliability, should be seen as a meritorious method of expressing the level of confidence of occurrence of an event, because it has got a sound backing of rules of human thinking, which essentially bridges up from plausible reasoning, which we call logical reasoning. So, we discussed about the qualitative and quantitative rules. I wish you should go through them in detail with the help of support material available in the website given in IIT Madras in this particular course. If you have any difficulties, please do write to me. Try to rehearsal yourself in deriving these rules, because they are very useful in understanding and explaining plausible reasoning and connecting them with probability theory. Later on, we will be using them in reliability analysis in subsequent lectures. Thank you very much and bye for now.